Good morning and welcome to the CADclass podcast. I'm Josh,
I'm Jake.
and we're here to talk about the cool stuff that you make each week, answer your questions, go over some things I think in our Discord that we're not always so confident answering in words, and hang
That's
out.
it. Yeah, that's a good way to put it.
Right.
I feel like every single time that we say, yeah, go to the Discord, we have such a fantastic community. And every once in a while, I can just so see these questions that I'm like, oh, if I could just speak to them directly, just no, the button's right there, it's right
Yeah.
there, or just change the view, just do that really quick. It'd just be so much easier. But
Exactly.
oh my god, I do love our Discord. I think it's one of the best things we've ever done. Is
Totally
just
is.
building up such a rad community.
Totally
God, I
is.
love
Some
you guys.
shout outs this morning to get started. So
Yeah.
Spitfire, special shout out to Spitfire. So he's here in the area in Sacramento, and he attended RC Fest, and which is RC planes, RC cars, RC all these kinds of things here in the Sacramento region. He passed out some flyers for us, talked a little bit about CADclass, talked a little bit about how he integrates.
He passed out.
Passed out, yeah. Talked a little
He's
bit
so
about
excited,
how
so
he
stoked about RC planes. He's done. He's out for the camp.
Yeah, he's leaving the community for good. But no, he passed out some of our flyers and talked about CADclass and how he integrates 3D printing into the plane builds that he does. And I know we mentioned some of the work that he does with, he works a lot with basically like lower density filaments, which is really cool because they're trying to reduce the weight of some of these planes. So big shout out to you, Spitfire. Ogre, we're going to show off some of what you made.
What's really quick, I just wanted to chat about that. So I feel like I learned about this expanding foam PLA years and years and years ago, and I've only ever heard it say, or for anyone that doesn't know, low density PLA. The idea is that normally you want your filament to stay basically the exact same density before it's melted and then after it's melted. But this expanding PLA, as the name implies, as soon as it goes through the hot end, it puffs up a little bit like styrofoam. So it physically takes up more room, but with a lower density, just like styrofoam, essentially. And I always heard, best application is always like RC planes.
Yeah.
And I'm like, that's so rad. And then I saw someone, I can't remember, I can't even remember who this was, but they just submerged their PLA in water. So when it was feeding into the filament, all that moisture would turn into steam and it would puff up the PLA anyway. and they were just like jerry-rigging low density PLA by ruining their own filament.
So he says he sets the flow rate. Genius. He sets the flow rate at 50%. Interesting. I'd like to see. Yeah, I'd like to see some photos of that. If you get a chance to fire and you're in that in the Discord, just shoot us some photos of what you make with that.
Do you know what'd be really rad? Have you seen the videos of those the guys that have the oh gosh, I'm not even sure what it's called. It's like a special tiny camera that they mount like right in front of the hot end. So you have like this close view of the hot end extruding filament. Have you seen those?
I have not seen those. Yeah.
It is so rad. I can't remember what it's a special type of camera. I think it's called like a tunnel lens camera, something like that. Nozzle cam. Yeah, that's it. Thank you very much, Ogre. It is so rad. And I feel like seeing that view with expanding film, it would just be so rad. I will say though, apparently some of the people who have done that, they've accidentally put their camera too close to the hot end, and as soon as it starts printing, their camera melts. Just from the radiant heat.
Oops.
That sucks. I'm sorry.
So down the list here, good morning, Ogre. We're going to show off some of what you make. PC Van Vliet, Sam Derry, Elareth, Rog, Johnny Yurtafan, Cadence. We got some people coming out.
Coming every week. We always really appreciate it. Josh, I think we should kind of start off as we always do, showing off the rad projects of our community.
Totally show off some rad projects, and we've got some fun stuff coming in.
I know what I really dig. Just before we dive into that, so I'm sure you guys know. Last year we won the Sacramento Innovation Grant, so we were essentially able to give and educate 24 members of the Sacramento community about 3D printing, CAD modeling, and essentially borderline product development, because a lot of these people that we handpicked on purpose, they literally have some ideas or some passion or some business potentially ideas going into it. So with these tools, with the 3D modeling and 3D printing, they're like 5 steps into the product development cycle. It's like you'll still, if you want to develop a product and you already know about 3D printing and you already know about CAD design, and you have a little bit of information about manufacturing and what works best and what doesn't, and then you can reapply that into a secondary or tertiary version of your prototype. God, you are so far ahead of the game. Like, because
Totally.
people who are, they've gone through the whole product development cycle without a ton of hands-on making experience. And good God, it costs them tens of thousands, sometimes $40,000. And I feel like if you just knew a healthy amount about CAD, you did a pretty good amount of research on how plastic things are manufactured, for example, and you knew about 3D printing so you could actually have it in your hand and do some quick tests. Good Lord, how much money could you save? Just be
It's a
ridiculous.
game changer. It's like a money versus time thing too, right? Like,
Yeah,
I
true.
think the product development firms are just used to dealing with these things over a long period of time. But I think
Mhm.
the thing that I'd like to talk about every week is just how you have access to the world's machines if you know how to make a CAD model,
Yeah,
right? There's no
yeah,
reason that you need to have $1 million machine shop. When you already have access to those machines, the only thing you need to figure out is how do I communicate my ideas with people who use those machines and then have
definitely.
other people make them for me. So
Yeah,
I think well, you know what 3D printing allows us to do is just get better and better and better at making CAD models and figuring out design and manufacturing processes. And you don't even have to, a lot of times, like you are thinking about it, but because you're troubleshooting as you go, it doesn't feel like learning in the same way as sitting in a classroom. But man, are you learning a ton.
no.
Man, are you
I
learning a
d
ton.
I've got a quick tangent before we go into it. It's a story that
Yeah.
I can't remember if we've told before, but I loved shouting out when we used to teach 3D printing, at the old shop. So one of my old mechanical engineering professors, he used to be the head design engineer for Oakley, um, back when it was relatively small company. And this was, I think he said 1980. So it's before 3D printing, but certainly metal CNCs were kind of ubiquitous in the manufacturing world. And he would say, "Oh yeah, we would spend, I think, somewhere like $12,000 in 1980s money." Thank you. Um, like 12 grand, which God knows how much that is now. They would essentially have start out with this massive, massive chunk, a billet of aluminum, and it would carve out like glasses. And then they would injection mold it, and then they would hand it over to their CEO, and they would look at it and go, "Can you make this just a little bit more curved there?" And yeah, and that'd be good. Yeah, just do that really quick. And my professor, he said, "Oh, my heart dropped every single time because that's another tens, maybe $20,000 just to get another prototype where it's just a little bit more curvy." And he was like, and it would take weeks to prototype to get it shipped out and redesign and get it. And he was like, it was gigantic. Like the amount of time and effort and money that used to go into prototype engineering was was unreal. It was really unreal. That's why when you think of, old school cars, the designs in certain firms barely changed, and in certain firms changed radically, because it's like, well, I'm not going to put all this effort into just doing a little tweak. It's like, it's either, no, you either change everything or you change nothing.
Yeah.
And then he said, and then, late 80s, early 90s, SLA resin 3D printers started to become a little bit more ubiquitous and started to get, attainable for certain companies. And he said, and now I could make an entire set of sunglasses for, I think they said, like 12 cents. And it would take like overnight. He would like finish up the design, print it, go home, come back in the morning, done, show off the CEO. Can you make that a little bit more curvy? Yeah, no problem. Come back the next day and it's done. And he was like,
Game
it was
changer.
radical. Like nobody had ever even dreamed that it could be that snappy.
Yep.
And it's so awesome. And I feel
Love
like
it.
the only next progression of speed that I can imagine in that is like VR, AR systems, Like
Yeah. I wonder.
that's
I
as
think about
rapid as I can imagine.
Yeah, I think about it like the way maybe the way that we'll interact with making models. I still think making the models is probably the limiting factor for most people, especially hobbyists. So
Yeah.
I wonder what I'm like super curious about still with AI and how it's it will eventually change the way we think about these things is how specifically, right? So if you put on virtual reality goggles and you start picking up objects in space around you, and then can you easily edit those? Can you make modifications to those? Like, what is it? How are we going to change our design paradigm to
I
accommodate
think
this
the
new style
easiest
of
thing,
thinking?
if like, I just saw a video of somebody who has one of the Apple Vision Pros, and they were able to like set up a shop inside their room, and they would actually go and pick something up, look at it, and go, "Nah, I want this one." And just the idea of grabbing something and, oh, it's something on Amazon. They have 20 different colors, and going, blink, I want to make it green, and then, oh yeah, no, that actually does look good, and then buying it that way. I can imagine that pretty
Yeah, and
easily.
I can also imagine the vision getting good enough to know what it's looking at, not just like a camera,
Mm,
but like let's say the little dial on your camera breaks. I can imagine computer vision
mm,
being good enough to say that this is the dial that you want. Here it is. Here's the STL file for it, right? And then your
that'd be
microwave
sweet.
3D printer, you just it's like, would you like us to send one of these to your printer and just have it ready for you, right? Like that actually I think is within reach. But I'm so curious. Like I keep I go back and forth with AI. Like we use it quite often, but
Yeah,
part of me is like, I'm not sure how it's going to change the design paradigms yet. I feel like I should know that. Like I should have some
I know.
intuition around how that will change, but I really just can't tell.
I
I
think
just
we
can't
both
tell.
agree that the of what we've seen so far, which is quite a lot of people trying to make CAD as AI as possible, which I think is a good talking point. And what we found is that it's actually fairly good at making single simple components that you would use in a design pretty well. It's if you see, oh, I want, instead of hunting through 9 pages of McMaster card to find this one specific bolt, if you just say, oh, this is what I need, and then done, it's actually fairly good at that right now. But then to make the entire model with all of those bolts and washers and nuts and panels and this and that, definitely not. Definitely not right now. But that's what we were saying, a couple of years ago with AI arts. It's like, yeah, it's kind of good for some things, but no. I mean, we said that for ages. Like, this is again a little bit of a tangent of a tangent. Some of the first CGI movies. Technically, I think the first CGI movie was a film called The Abyss, which I've never seen, but I've heard it's quite good. And it's essentially just this weird mirror water liquid character that flows, and it can reflect the environment, and all of the physical prop makers were going, oh, that's amazing, but it will only ever be used for psychedelic, strange, stuff that couldn't exist in real life. It'll never actually replace, an environment or something that you hold or something in the sky. And then it's like very, very quickly that changed. So
Yeah.
everything that we're saying, we're just holding our tongue pretty firmly. It's
I
like,
think the
yeah, it doesn't work
word
right now, but
well, I think the word augmented still really when I think of AI, what I really think about is not necessarily replacing humans, just making them much, much, much more effective. So
well, augmented
finding those
reality,
use
that would
cases.
be AR, or artificial intelligence would be AI.
Totally, but I actually when I'm talking about AI for artificial intelligence, I'm actually imagining things that augment our ability to do things. Like, for example, when you need to write an outline, in the past, you would have to go, "All right, what's bullet point 1? What's the right?"
Yeah,
Now
yeah.
you could say, "Hey, ChatGPT, we're working on our second Fusion book. Can you give me some sense of what all parametric CAD softwares, what you need to
Mm,
know? What are the fundamental skill sets in it?" And it kinda, like,
mm,
jams out something that you go, "Wow, this is
yeah,
not perfect, but I'm, like, 75, 80% of the way there." And
yeah.
so that's how I tend to think of it. Like if you already have an object and you need to make a modification to it that's quick and easy, that's understandable in words, maybe
Mhm,
there's something like that that does it. And I saw something else. Key to like said, someone has already made an experimental generative 3D model creator. Yeah, so there are
mhm.
generative 3D model creators. I will say I have not
I
found any
have
use
I've
whatsoever.
played around with it. There's one called, oh god, completely forgetting the name. It's on Discord. It's Discord based, just like Midjourney, but it essentially is only really good for Pixar artistic blender like 3D models. Like, oh, I need a bumblebee character who's very cute for a 5-year-old audience, and it can make that really, really well. And it adds color, not a ton of polygons, but that's fine because it gets you most of the way there. But yeah, with AI, it's kind of funky. I did see a Reddit post yesterday, and someone said, Wow, since the ubiquity of AI is so popular, nobody's really talking about the Turing test anymore. And somebody commented, "Yeah, it turns out fooling a human is actually way easier than anybody thought." They're like, "Yeah, no, it's not difficult."
That's hilarious.
That's
That's
great.
hilarious. There's a so I was reading something yesterday actually on AI, on the topic of AI, where simple questions were asked these AI models, and one of them is,
Mhm,
"What weighs more, a pound of feathers or a pound of lead?"
mhm.
And the answers that AI gives is really funny. They're like,
Is it
"Oh, a
bizarre?
pound of lead weighs more because it's got a higher density," and then it goes into all this justification about how
Oh
a
my
pound of
god.
lead weighs more, and then you start to really mess with it, and you can go, "What weighs more, a pound of lead or 2 pounds of feathers?" And it will get even wackier, and all of the models kinda botch it, but they botch it in
That's
unique ways.
amazing.
It's so amazing. I don't know what I was like reading
That's good.
my buddy's about to start lecturing today. He's a professor over in Europe, and today's his first lecture, and he's like, "You gotta read this article
That's
about
awesome.
how AI interprets things," because he was talking about, like, what happens when these agents start to interact with each other. It's a big question. You
Mm,
have one AI model that starts to have a conversation or in some way interact with another AI
mm,
like, what actually happens when you do that? And then we got kind of philosophical about it because it's like, well, what is an agent? What's a single agent? Is this just one
mm.
like, and you very quickly get into this spiral where you're like, "Oh, I don't even know what I'm talking about anymore. Like, what 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 is this
That should
going
that
on
should
right
be the
now?
title of this podcast. We don't
I don't even know what
really
I'm
know what
talking
we're
about
talking
anymore."
I don't even know what I'm talking about. I
Yeah, so I
I
got some let's show some stuff off, and then remind me,
I think
like,
let's show off some stuff.
I wanna talk at some point about saw stop. I don't know if you've seen the legislation coming down the line, but,
I have
I'm gonna
not.
tease it a little bit.
Okay.
There's some stuff happening in the world
Is
of
it a little
woodworking.
juicy? Okay.
It's a little juicy. Oh,
As you broke your chair. Okay.
literally
Let's
just
show
broke my
off.
chair.
Oh my god.
Alright.
All right. Let's show off some of the rad projects on the I made a thing. Oh yeah, where were we last week? So
I think
after
we got up
everyone's
yeah.
making twisty bit, then we got ZDP, who's a very fantastic CAD designer using Tinkercad. Looks phenomenal. Working on it, it is, and then getting into the thread. Threads are not easy. Threads are weirdly difficult things to do. Yeah,
And and
it's
that's in
definitely
Tinkercad.
yeah, which is even
That's
more impressive.
outrageous.
Yeah, that's a tricky thing. This Dr. Venable, is that person they're part of our new innovation group, right?
I don't know. I don't know. What does it say?
My very first design, wife's friend has a bunch of these markers and keeps them in a Ziploc. She wanted them. She wanted something that they can hold them all easily to show all the colors that they have. Possibly could have made the base and top a little thinner, but for now it works. This is
Very cool.
that's rad. This is reminding me. Um, so my partner used to work in a COVID laboratory, and something very similar to this, where you put all of your test tubes and everything like that, all the testers, and it was 3D printed. And I was like, "Oh, who did you get to 3D print it?" And they're like, "Oh, something something something." Can't even remember who it was. And I was like, "Oh, that's pretty rad because it doesn't. All the tubes are already sealed. Obviously, there's no hygienic thing that really needs to go wrong with it. But the previous one they bought that was just metal, it wasn't stainless steel, it's just aluminum. It cost something obscene, like $800 for essentially just like a grid rack. And it's
So,
good
dude,
lord.
the bio companies that have
Hmm.
a stronghold on the purchasing departments of these
Hmm.
institutions,
I know you have a lot of
it's
experience with it. Yeah.
such a racket. Right? So especially those test tube holders. It's like, why the hell is this thing multiple hundreds of dollars? This makes
Yeah.
no sense whatsoever. This is 10 cents of plastic and one injection mold. So, I mean,
Hmm.
kudos to the businesses that figured out like there's a business called
Yeah.
BioRad. They're a big distributor of equipment and their margins must just be insane. They just figured out how to get into the institutions and just
Yeah.
completely overcharge by a factor of 100. And a lot of times it's funny
Yeah.
too because like there is some pressure to spend your grant money. And if you don't spend
Yeah.
it, it ends up actually reflecting negatively on you. And so
Mm.
there's this weird pressure where people were like, I gotta buy something. And so
Yeah.
you get a kind of a wasteful overspend in a lot of cases. Not necessarily true of the COVID lab. Obviously, they're trying to make a
Mm,
profit there. But
yeah.
yeah, I always thought test tube holders were one of the low hanging fruits for 3D printing, and I think there's
Yep.
honestly there's a lot of big business to be had working alongside of researchers. There's a lot of
I
customized equipment
completely agree.
that people need over and over again. There's a lot of stuff that you could reduce the cost by 10, 100, maybe even 1,000-fold in some instances.
Yeah,
So if you guys are
completely agree.
anybody in here is looking for a market to pay attention to, I would say the bio market is really interesting.
Yeah. But coming back to it, rad project. Very, very nice print as well.
Yeah.
Lovely, lovely, lovely. But what I'm noticing, so this is I don't know if you guys can see on the screen. This has got a little bit of a speckly surface quality on it. So that's going to be the actual surface of the print that when you pull it off and then obviously put upside down, any of that texture on the surface is now kind of perfected onto the top of there. That's why I see a lot of people going, "Oh my gosh, how do I get a lovely smooth surface on the top of my print?" And a really quick fix is just print it upside down, and then where it's touching the bed, that's now the top surface. Oh look, it's really lovely and smooth, or very uniformly gritted, which looks really neat and professional. Where you can't even tell that it's 3D printed. So good little trick, rad print. Love to see it. Um, this looks like an even bigger project. So, made platform to hold index cards to CNC, for my CNC to draw during Maker Faire. Also made a pen holder. This is so awesome. Did we go over this last week?
I don't think
So,
so. Did
I
we?
remember. I remember seeing Dom.
We were
I'm pretty sure Dom is just pretty active in this.
Yeah, so
Posting
Dom is
loads
down
of
in
stuff.
Orange County, and he
Yeah.
works with Maker Faire OC
Mhm.
quite a bit. And then he came up and he watched our talks up in San Francisco when we spoke at Maker Faire in San Fran as
Oh
well.
yeah, that's right.
Yeah, I
Oh my
bought a
gosh,
book, and I think he may have bought a book there or has bought one at some point. So yeah, big shout out,
I
Dom.
think so. I totally, but yeah,
Yeah,
of course he did. Yeah. And then yeah, making little holders for index cards that you can then print and or that actually looks almost like a laser pen. Hmm, funky. But yeah, what a rad little project. Just taking a machine that already exists, making a couple 3D printed fixtures onto it, and then you turn it into a completely different tool. That's
really cool.
so rad. That is so
Really,
awesome.
yeah,
I
really cool.
also really dig this little box on the right hand side of the
Because it's got
menacing red button.
hexagons.
No, because it's like it's got an ominous red button. I feel like
Hmm,
every mechanical thing needs to have an ominous red
an
button.
ominous red button.
It's still one of my projects. I will get around to it one day.
An orb.
Um,
ORB.
no. I have this like comically ridiculous big scary red button that just get to hit it. And I have wanted since I was a child watching like old Batman shows and all different. Oh, there's a person that has like a hidden cave behind a bookcase kind of thing, where they have this marble bust and they tip the head back, and there's a button there, hit it, and then a bookcase opens. I've wanted that since I was a boy, and I'm like, I have marble PLA, I have the button, and it's been on my growing list of projects to do, but since I was this tall, so I will get to it eventually. If you guys have any suggestions of who the bust should be of, definitely post it in the comments, and I'll try and make it. I found this model of Darwin's bust. He's got a lovely, massive, gorgeous beard that I'm like, oh well, I can just kind of use that as a hide for the seam when you tip the head back and click the button. So something like that.
That's funny.
But coming back, awesome project on. Coming from Ogre, purchases a very inexpensive rotary tool and wanting to be able to mount it onto small working pieces. Yeah, Dremels are super duper handy, but working on tiny projects, so scary, so scary. Also makes it easy to remove and store simple design squeezes on clamps onto the device.
Super
That is
cool.
so awesome.
Super,
I
super
love that
cool.
so
Yeah.
much.
Ellereth says
I
the bus should be of Josh.
just I know, but I feel like if I have like a marble bust of Josh, I'd be like, oh, Josh is dead.
Yeah.
No, he's not. I just
Awesome.
get like really bummed out all the time.
Yeah.
Rad, super awesome. These are not hard, by the way. I know people looking at this go like, oh yeah, it's just like a little holder and then a little saddle and bumps. The weird, intricate design of a lot of tools is so much more difficult than people expect.
Yeah.
Like
Yeah.
the
The
trying to
contours
measure
and
around
mhm.
weird uh tapering cylinders with grips in different areas so you can never get a real diameter, way harder than it looks. I've got a
Yeah.
lot of experience with that and it's a nightmare.
And
Yeah.
even the, like, little design features that'll have, like, ridges and bumps, and
Mhm.
you don't recognize when
Grips.
you're looking at products just how much of that product is like a specialty feature, and when you're modeling your own
Yeah.
simple stuff, you're like, "Look at this crazy thing I'm it's all smooth and flat surfaces and
Yeah,
nice
yeah. And they're like,
curves."
"Why doesn't it look like a final product?" It's like,
Right.
look at any drills and you'll realize they
Oh,
have got like
man.
random cutouts and grooves and rubber surfaces for grips, but it's on the side where you would never even grip. It's just, yeah, it's full
Yeah,
of it's one of those things where all you have to do is add just a tiny bit more design and it looks like a product. And it's that much more work. You've put the majority of the effort into designing a drill and it just takes a little bit extra to make it actually look professional. So anyway,
totally.
awesome, awesome, awesome. And
Key to
then
like,
Heat Alike,
hanging out.
uh, yeah, rad. Trying to recreate this cutout design or this cutout demonstration lock of the goal, eventually also modeling the pins. So they're actually trying to model a lock with all of its pinions in it. That's pretty impressive, dude.
That's
That's
cool.
so
That's
awesome.
cool. And
Yeah,
he's in
that's
our
rad.
Stack Innovation program here.
Mhm,
Super, super cool. I honestly think that one of the best ways to understand things, we were talking about this last night in our private, Zoom
mhm.
session, but one of the best ways to learn how things work is just to try to model them, because you
Yeah,
recognize like, just how little you know, kind of to your point about even about the drills and how many little design features there are. It's one thing to
mhm,
look at it and to start to think that you notice things. It's a
mhm.
completely separate task to try to design it. You get in there and you go, "Okay, I
Completely agree.
looked at it and I thought I understood, and I thought I had an appreciation for how much, like,
Mhm.
nuance goes into this." And then you start to try to model it and you go, "Oh my goodness, this is
I know.
way more." Right? Like, this what is going, and you just recognize, like, wow, it's
Mhm.
pretty complex stuff.
And and I'll just kind of add on to that, and I can't even see you, Josh. Just to add on to that, when we talk about people in the professional manufacturing space that are actually doing 3D designing and 3D modeling, you can kind of put it into two separate categories that I see all the time as far as like job listings. You've got CAD technicians and CAD engineers. Usually, CAD technicians are paid significantly less than CAD engineers. And you'll usually kind of hear CAD technicians being called things like CAD monkeys, where it's like, yeah, give them something and then they just make it and then it comes back and it's done really quickly. But the defining difference between the two, between an engineer and the CAD technician, they can both create the CAD model, but the engineer actually has some information within the manufacturing and how it can be improved and how it can be changed. If it's a prototype, where it might go wrong, how they can kind of prepare for that. If it does go wrong, how they can fix it. And so they have a significantly more on-hand manufacturing background with whatever they're designing. Whereas if you give it to a CAD technician, they may not know everything about plastic injection molding or CNCing steel that changes for CNCing aluminum with your design or any of this stuff. You know, if you are designing a CNC cup, for example, and it's like, hey, the CAD technician made it with like sharp internal corners, then you know they'll hand that off to a machinist, and the machinist will go, this literally cannot be made how you think it could be made. But the CAD engineer will go, oh, I actually need, you know, a rounded fillets on the vertical. And it's like those little tiny bits of information that you come into designing with CAD. And as long as you know the tool that it's being made for, it you no longer are in the category of a CAD technician. You get bumped up to a CAD engineer. So if you have this like artillery of tools where you go, oh, I've got a laser cutter, or I've got a cry cutter, or I've got a laser engraver, or a 3D printer, or maybe you're getting into the CNC hobbyist space. If you are now designing your projects specifically to be done with that tool, and you know roughly where something may go wrong, or you're designing around one of the tool's downsides, then you are miles ahead of a CAD technician. Seriously, miles ahead.
Definitely.
And that's really what you should be striving for. Not just can I make the model, but can I improve it if I was going to be making it out of plastic or out of aluminum or out of wood. You know,
Well,
it definitely changes.
and it kind of gets to some other points here, I think, that are really interesting to chat about too. And that is, what is your intent? Is your intent to make 1,000 of these, 100,000 of these, or just one? How long does it need to last? What are the heat
Hmm.
considerations? The material science side of what we're doing, you definitely learn by doing it. So, you
Yeah.
get your hands on, you make stuff, you figure out where it has a weakness, but you only really figure that stuff out by doing a lot of it. But that design intent is something that we plan to include at least somewhat more in the second iteration of the book,
Hmm.
because we recognize that by not giving you that context, we're not allowing you to grow into the potential
Yeah. Yeah.
CAD
You kind of
engineer,
in
right?
the
Like
dark about it.
we're kind of leaving that up to you to figure it out. But yeah, it's a major consideration is where might it break, and what happens if it does, and what might the consequences be, and then also, how do I chat with a machinist about this, and what are they likely to ask me? And so yeah, I love that. And I even think approaching your projects where you go, even explicitly you say, my intent is just to make one of these things for myself to see if it works in a
Mm.
notebook that is your design notebook. Even being explicit about it, even though you're probably already doing it by default, I think can be really handy as you
Yeah.
as you progress and learn more and figure out what you know and both what you don't know. And then you can go back and look at your journal and you can say, oh wow, this was my design intent, but I didn't succeed, or I did succeed. What do I need to do to change it? Let me make some notes about what I changed and why I changed them. And then over some period of time, you've got a repertoire that you're developing because you've kept track of things and you were explicit about what it was that you're trying to do.
Yeah. Yeah. It is I think it's probably single-handedly the best thing that you can do to really kind of level up. Not only is it designing your own stuff, but then really starting to understand the upsides and the downsides of the tools and then apply that directly to your projects. I think that is one of the best things that you can do probably.
I
But
agree.
but we have a lot of people who don't have access to certain tools, that have access to big CNCs or anything like that. So one of the things that we both recommend massively, go to your local library. It is very likely that they have
Or
some 3D
community
printers,
college, or
community
college,
college,
or makerspace,
or a makerspace. That's where
or
Josh and I met.
workshop, or
Yeah.
like there's all kinds of places that you can
Or
find these
good
machines.
lord, Craigslist. You can find tremendously cheap 3D printers and CNCs on Craigslist. Most of the time, people just like, yeah, I bought it, played around with it, couldn't figure it out. $20, and it's like done, sold.
Yeah.
I'll take it. So
Yep.
full
Love
of a
it.
bunch of cool stuff. To actually answer one of our community members' questions, they were having a little bit of trouble with the oh goodness the smartphone project. So that was I can't remember who it was actually. It was TC. They were saying that they were a little bit confused on this project, where to get the offset lines for actually making the case. And what I believe they're having a little bit of trouble with is they're in the wrong perspective. So we just wanted to take some time and go over this specific part of the project, which is kind of one of the best things about doing this podcast, is that responding may not be the best way to translate the information. It gets a little bit confusing. So doing it actually on live to show you guys the actual process makes life a ton easier. So this is the final project where we have an iPhone 12 or no, a smartphone 12 with no brand name, with a case on it and then a wooden phone stand. But actually going through all of this, we actually want to start fairly simple. So the idea with starting off with a phone and then making just this bumper case around it is that you can make the profile of this outer case that is just an offset from this surface, from this outer surface of the phone, and then using any of these lines that wrap all the way around the phone, essentially as a path to sweep that profile. So we just wanted to go through this pretty quickly and just show you guys all the processes that goes into it. So we wanted to start off, if you do want to follow along, this is in page 148 of the book. So you start off by making an offset profile that is 50 millimeters up. And then the majority of the difficulty that I think TC is getting stuck in is the sketch portion of it. So the idea is that you just want to be projecting the 8 surfaces or the 8 points of this phone. And I think what they may have had trouble with is that they had the front perspective where there is no angles, and that can be a little bit confusing. But the top section is that you do want to project, I believe, the 8 lines. So 1, 2, 3, 4, 5, 6, 7, 8, or 9 lines, but 8 points. Then you can make an offset, which is you can see right here is in green. I'll actually redo this, to be honest. Makes it a little easier to see what's going on. So I can turn on. Actually, no, yeah, I'll do it from scratch. So we'll make that new offset plane from the top surface. This wants to be up 50 mil. Then I want to make a new sketch on that plane, and then I would like to project these points. So you can see that top corner. What was it letting me select there? That's fine. I can just select that line. That'll give me the endpoint all the way around. There we go. And then I also want to be clicking the top and bottom as well, just so I can get that nice little offset. So right now, these are purely just points. And you guys can see it right now, but these are purely just points on our project. And so now we want to use our line tool to actually join all of these. So we have very, very defined lines between the two. Whoops, messed that one up. And the real difficulty with this is not so much doing the project, it's actually seeing what you are doing, which can definitely be a tricky part of CAD, where you go, I kind of get what I'm doing, but it's a little hard to see, and it's just kind of trust the process. That's the idea. So as soon as I have all of my lines that kind of encase the side of our phone, then we can type O for offset, and then we can select all of these lines that then wrap all the way around our project. So you can see it's actually going inwards. So I'm going to be clicking flip down here, or I can type in -2. Then you can see it punches out a little bit. Then I can click OK, and then actually use my line tool to say, all right, I want to make some vertical lines to kind of cut these off. Those two lines want to be collinear, so they kind of extend into each other. So that's pretty simple. That's just a constraint. The whole thing is set with a 2 millimeter offset, so I'll do the same thing. Say 2 millimeters from that point to that line. There we go. If you can see, or can't see, this inside profile is actually the same color as this white outside. So there is no enclosed profile right now, and that is because one of the endpoints of this line is white, which means it's movable. There was an ever so slight gap between that point and that point. You can see on top it is black points, because it's actually coincident with it. So we can just click on the coincident tool, click on the white dot, click on that projected line, then it's connected, and now I have an entire enclosed profile that I can work with. And if you want to, you actually don't need to too much, because you do have an enclosed profile, but you can trim away this top line and this bottom line. You can click the trim tool, or you can type T, click and drag. It works just like the eraser tool. As soon as you do this, the neatness of the project kind of disappears, because now all of those offsets are now individual dimensions. It's not the entire thing is offset, because we've carved off some information. But that still leaves us with this enclosed profile, which is completely fine. Then I can finish that sketch, go into the sweep tool. That profile is already selected, and then clicking on the path, and I can essentially click any of these lines that follow the route of the phone. Doesn't really matter whatsoever. You can pass it all the way around. You can see it's red because it is intersecting with our phone at some point. But we don't want to cut away this. We want to make it a new project. So in the operation, instead of cut, we can say new body or new component. It really doesn't matter. And then the rest of the project is going to be seeing where those buttons, where the buttons and the switches and charging and everything like that, where do those interfere with this outer body? So then you can cut that away, make the backing of the phone case, and then it's done. But this is a really good project. I actually fairly like this, because part of the ethos is, yes, you can download this phone off the website. It's a little bit unnecessary, because we want this to be an example of how you actually do make your own phone from scratch. Any smartphone that you have, guaranteed some of the dimensions are going to be available online. You can look up any smartphone at all, and it will give you pretty accurate dimensions. The thickness, the radius, where are the charging port, how large is the charging port. all this information is super duper readily accessible. So if you've done the project just by downloading the phone, that's great. But we do highly recommend you try and recreate your own phone from scratch and then making a case for it. So you can follow almost identically the exact same steps in the book and just apply it to your project. There you go.
Great.
Hope that helps, CC.
Yeah, so PC Van Fleet says, quick fusion question if you guys don't have another one already. When clicking on things and using the constraints, is there an order in the clicking as to what gets constrained to what?
Sometimes, really good question. So, for example, if I have the two lines that are like that, and I'm using the parallel constraint tool, one of the ways that you can do it is you can click on the parallel constraint tool. It's now expecting you to click two objects. Obviously, you would click both the lines, and then they become parallel. The other way to do it would be to hold down Control or Command, and then you can click both of the lines. So now both of them are highlighted, and then click the parallel constraint. So you can do it either way, but there are a couple constraints where the order of operation is really important. That being the symmetry. You have to make sure that you click symmetric constraint tool, then object 1, object 2, and then the line that it is symmetric about. That's the really important operation. If you mix that up in any way, it will not work.
So which line moves for the parallel constraint? If you click, is it the first line moving to the second?
It's the second one moves to the first one. I think. I don't know.
I think you're right.
I think that's about right.
Yeah.
But I believe we just published a short about the parallel tool. So if I'm wrong, I do apologize. But you guys can go and check out that short right now if you'd like. But I do actually have a project that I want to, or a question to the audience actually. So I am still working on the frame for our reprinted series. For you guys that don't know, we're currently working on a really large series projects where I am replacing every single or as many parts as I possibly can of an Ender 3 3D printer with a 3D printed part that is made on the machine itself. So currently working, or I made all of the bolts a couple of weeks ago, and just because I know how difficult this is, these have to be really beefed out. But these videos are all about cramming as much information about 3D printing, slicing, but more importantly, CAD for 3D printing. So, for example, making an M5 bolt out of plastic, it would just snap. It just sucks. So one of the things you'd have to do is just increase the diameter of this. Oh, then the thread is too tiny. It doesn't actually work with the resolution of 3D printers. Okay, you have to go make a little bit more of a chunkier thread. Well, this is now an Acme 3/8 thread. So there's all of this iteration to it. And the next process is making the big frame. And every single piece that I've printed has taken like 12 to 18 hours to print. So it's a little bit behind schedule. I do apologize. But all the parts, they literally just finished this morning. So it is coming down the line. But this is one of the parts. This is the middle of the base. There we go. This is the middle of the base. So it has the cutout. It's got all the threaded holes on either end. But I actually ran into a really funky problem that I've had before and I've never really solved. And the problem has just kind of gone away. Just very, very randomly. And that is, I'm not sure if I know the correct name of it. I think it's called pull in. That might be the name of it. But it gives me this fantastically ugly surface finish.
Oh,
look at that. Do you see how gnarly that is?
Yeah.
Really ugly. So just for example, the other edges of this project are super duper clean and crisp. All the corners nice and sharp. Looks good. Except for, if I can get that. Oops, where is it? Oh, goodness sake. Except for right there. Super duper ugly. So what's going on is this is the seam line. This is where the layer starts and ends. And this is where it is actually starting off from. So it'll finish coming all the way around the way there, finishing there, moving up one layer and starting. And what it looks like in real life is that there isn't enough material being purged out and then as it's moving, more and more material is coming. It's kind of intermittent, and then it gets its act together, and then it flows out nicely. This is the only piece that has this problem. The rest of them look beautiful, and very annoyingly, this is facing up. This is not like, oh, it's hiding. This is very visible, and I hate it. But I've had this problem in the past. So, just a little bit of context. If you are having this problem, there is, or if you're having really bulging themes where it's really blown out and ugly, there is a thing called coasting, where before it makes that corner, before it finishes that layer, it will actually stop extruding, and you set it to a volume of material, usually like 0.04 cubic millimeters. And essentially, you are just allowing the 3D printer, when it is moving upwards to the next layer, and it's not actually extruding any information or any material, gravity is just letting that material flow. And we're saying, hey, stop just a little bit before it's done. Allow gravity to fill in that space. And by the time it's moving upwards, there actually isn't that much material that's just kind of dribbling out of the nozzle, and then it can move on. That works really, really, really well. And you can dial it in to get a pretty minimal Z seam. That's one of the best tricks of this. If you radically, radically increase that value, then obviously it means that it's finishing extruding here. So then by the time it's working over there, it's like, hey, there's no material to fill in the gaps. You literally have to wait for the filament to be extruded and then put into it. So I've done that. It is, or the values on this are not special or tweaked at all. These are the base settings for the Ender 3 on Prusa Slicer. I haven't touched it at all, other than like infill and wall count. Other than that, everything is absolutely stock. And I've had the same problem with Prusa and Cura as well. Just repeat, all of the other pieces, all of them are perfect and beautiful. This is the only one. And the only difference is that there was a little bit of, because it's such a long piece on the Ender 3, and the heating element of the bed is in the middle, as you get further to the corners, obviously it's colder, and so things like to warp up. So a little bit of warpage on that corner, and then just ugly surface. So what the hell? Josh, I want your 2 cents. What do you think happened?
I honestly have no idea. I'm like sitting here
Yeah,
listening. I'm like,
I know, right? It's really funky.
it's really funky.
It's super duper ugly. It's really revolting surface,
It's
actually.
but it's fun. It's ugly in a like that looks like a reproducible ugly, right? Like it's got
Yeah.
this pattern to it that you go, well, whatever happened on repeat.
What I think is happening with the pattern is that it's a little bit of material is deposited and then nothing. And that then becomes a grappling point for any oozing material to then grab onto that. And it deposits
Interesting.
just a little bit more material. So you can see on that surface, it's actually, oops, cover my face. Come on. There you go. You can see it's kind of starting off at a small point at the bottom, and then it becomes larger and larger and larger. It's just funky.
Jerry
It's really
Jerry
weird.
says, does that pattern on the outside match the infill?
Nope. Nope. The infill is gyroid. And there's also 6 layers on this one.
And then
So
PC
there's
Dan please
no
says, does
connection
it
between.
change position if you rotate the part? In other words, if you print it on the bed, but at a
I only got this only happened once. And I guess I do have enough filament. I don't have I only have a kilogram of this special PETG cruciament. So I'm trying not to reprint parts if something is just visually. Like, this is strength-wise, nothing is going on wrong with this. This is strong as can be. Thankfully, all the threads still work.
Nice.
On this end. This is lovely. I'm actually really excited to be
This is nice. Jerry says, outside walls first or inside?
I have no idea. Whatever is the stock. I am assuming that it would be the outside walls first, because then after it's done with that layer, it wouldn't be depositing enough material, and then by the time it got to the inner walls, obviously it's kind of hidden. It's all solid. But I don't know. So putting it out to the world, I guarantee I'm not the only person that's dealt with this problem. I dealt with it on the past on a different Ender 3 version, with Cura, with all of my normal settings, with different filaments as well. I could never solve the problem. Just one day, it just disappeared, just like magic. I don't think I ever tweaked any of the files or anything like that. It just went away. And it's been this big mystery. I'm like, I don't even know what it's called. I don't even know how I'd even begin to fix it. Peace Van Bleed, try turning down the speed from 3 millimeters.
This is I think this was different question, but I've limited experience with Bowden. I think that was
all
an
of
answer
these
to Somalia.
suggestions. All these suggestions are great, but it only happened on this one. All of the other pieces were perfectly fine. So it has to do with this kind of minor warping. So, dude, just weird and funky and weird.
Super strange.
Super strange, right?
Strange. Yeah. Spitfire showed off the plane that he made in the 3D printing discussion. Check that out.
Oh, yes. Let's check it out. God, I do love showing off all the stuff from our community. It's like a guilty pleasure seeing all you guys' stuff. Whoa, dude!
It's amazing.
Oh my god! Good lord! All right, this is one of my 3D printed RC planes using active foam lightweight PLA. Can't take credit for the design, but hoping to create my own design once I've mastered Fusion. What? Oh my god, that's so rad!
That's so rad.
That is so flipping cool. And you can see all the little baffles in between that actually make the shape of it. Oh my god, that is so rad! I wonder if the entire thing is clad in a 3D printed material, or if it's just the structure. God, that is so awesome! And then that might be a wooden propeller. God, that is so rad. I'm trying very hard not to swear. Yeah, dude, that is phenomenally cool. That's so awesome. Weirdly enough, I've flown a lot in my life. I've never flown in a prop plane. Never have.
Oh, nice. I got the opportunity to do that last year for the first time.
Yeah, you did it in Alaska, didn't you?
That was rad.
Lucky bastard.
Just flew us out to the middle of nowhere, and then we went fishing, as you do in Alaska. It's crazy. That was crazy.
That awesome.
Yeah, so the saw stop. So there's something interesting in the maker world going on right now. So there's legislation.
For everyone that doesn't know.
There is
what a saw stop is.
So saw stop, for those of you who don't know, table saws are notoriously dangerous, like extremely dangerous, and more than 50% of all accidents in workshops, I think all workshops, are on a table saw.
Yeah.
Super dangerous. There's kickback. There's like if you put it in at an angle, the blade itself can like pull your fingers towards it. I don't know if you've gotten a chance, if any of you have seen the videos on YouTube where somebody tries to demonstrate how not to do something on a table saw and nearly cuts their finger off on the demonstration piece itself. So anyways, there's a lot of stuff going on trying to make table saws safer. And there's legislation coming down the line right now, potentially mandating saw stop. Mandating it. So saw stop, well, yes and no. So yes and no. So good and not good. Good is they're so dangerous and you could absolutely prevent a bunch of these injuries, right? Bad is it's probably going to triple the cost of table saws. So you can no longer, right? Because you can't have those hobby table saws are not powerful enough to have this entire integration into it. The blade itself, like the actual motors, like there's not enough in them. So you can't actually make a $250 to $300 table saw. You have to make like an $800 or $900 table saw. Now, clearly there'll be some competition, and SawStop has very generously agreed to not enforce their patent. They basically said, if you want to make this design and this legislation passes, we're not going to actually stop you from doing it.
That's
so
like
the question
when,
I have for you, Jake,
when the original seatbelt manufacturer, that like they could have made a killing on it, and then they just gave the patent out for the safety of humanity, which is like, God, that's kind of beautiful in a way.
And so Jerry's actually getting to something that I want to ask you about, Jake. And so Jerry says, yeah, just what I need, more nanny state telling me what I have to do for my own safety. So the question I have for you, Jake, and I'm a little bit conflicted about this one, but the question I have for you is it the state's responsibility to mandate these kinds of safety considerations with table saws, or is that responsibility on the individual owner of the table saw?
So I would say that just a little bit of kind of maker culture information for the crowd. So table saws are obviously very, very handy tools. They're very dangerous, but what you find with damn near every single accident in a workshop is that it's not just some person that doesn't know any better coming up to a table saw and touching it and cutting their finger off. That is that makes up a tiny percentage of the accidents. The majority of the accidents is someone going on the table saw and doing the same cut over and over and over and over and over again. And then after doing it for like an hour, they just get sloppy. They're not thinking straight. They're probably tired and they do something that they wouldn't normally do and they cut the finger off. When I was teaching woodworking back in the day, we I had a student who'd been doing woodworking. I think she said she'd been doing woodworking for like 30 years, and she was working on a project. She was on a jointer, which is essentially just a large, scary spinning blade with two tables, and you push it along, you get a nice smooth undersurface. And she had a pallet worth of material, cutting, 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 cutting. And one of the things that I always taught all of my students is set a 20-minute timer on your phone. And if any of your jobs take longer than that, you stop what you're doing, you walk away, shake around a little bit, go grab a coffee, go to the bathroom, play on your phone for a bit, send a text, go on a phone call, then come back. And that'll restart your brain. And if you do it for too long, unfortunately, she was not thinking straight. She'd have been there for an hour. You get in this weird meditative state, and safety kind of goes out the window. And she accidentally stuck her fingers into the spinning blade, and she cut all four of her fingers down to there. Massive safety concern. She then came back a couple weeks later to finish that project because she's a badass. And we obviously called ambulances and went through the whole safety procedure. But she said, no, it's completely my fault. I didn't listen to Jake. I should have stopped. It was completely my fault, completely my responsibility. But going back to what Jerry was saying, it's not that we are mandating safety. It's that the people that are doing this is not because they're stupid and they need everything to be bubble wrapped. Is because simple accidents, people not thinking, not because they don't know any better. It's just because it was a dumb accident. And unfortunately, the price of that is fingers getting cut off. In the same way that we mandate helmets on motorcyclists, not because we don't think that you're safe, it's because a certain percentage of the population are dumb and don't.
So
They don't think that they should be safe enough.
So the question is, should we? And your answer is,
I I like the idea of the safety mechanism being more ubiquitous and being shown across different companies, so it becomes more and more accepted as a standard feature. Do I think it needs to be on it? Probably not. Because if you know I mean, both Josh and I have been teaching woodworking for years and years and years. If I have never ever cut any of my fingers on any woodworking tools. But then again, I was a safety instructor for a woodshop, so of course I would know better. Of course I would know all this stuff. And it's one of those things. Like, it's like no matter how much you tell someone, hey, do this, do this, do this, it's not 100% guaranteed that they will be as safe as they should be.
Totally.
Like,
Yeah, I think it's just difficult
the
to
old
draw
phrase
the line.
the old phrase is OSHA regulations are written in blood.
It's just difficult to draw the line, right? It's like, at what point are we responsible for our own safety and not?
Mhm.
And I like the fact, to your point, I like the fact that it hopefully will become more ubiquitous. And I also like the fact that it sounds like they won't enforce this patent. But what I do dislike is, now, by tripling the cost of a table saw, are you actually preventing people from being able to get in the hobby in the first place? Are you preventing them from being able to make the choice that's best for them, right? Do we really need the state looking over us and saying, hey, by the way, you can and can't do this specific thing because it's dangerous? And like, where do we extend those danger parameters? Do we then mandate, oh, well, if we're going to have it on this tool, there's another, right? And so it leads to this kind of thing where I go, I'm pretty sure I still just believe in personal responsibility with a heavy dose of education, with a heavy dose
Yeah,
of let's
I
try to
but
make this as safe and comfortable as possible. And when the accidents are truly the fault of, the misuse of the tool or somebody pointing you in
mhm.
the wrong direction, then maybe we can do something about that. But I'm not really sure I like the idea of a state mandated saw stop.
I don't. I'm not sure. I think offering both options is. Do you know what it should be like? It should say, "Hey, you've got a normal table saw which is $500, or you've got the table saw with the saw stop mechanism which is $1,000." And they go, "Yeah, that's a $500 difference." And then it shows you the price of reattaching a finger in America, and you go, "Oh god, that's way more than $500. That's 20 grand." Okay, fine. And it so yeah, I don't know. I don't know.
It's a
I
tricky
get
one.
a little blurry lined.
Yeah. Yeah.
Just I mean, just a little bit of intercontinental information. So in America, or at least in California, if you're a pedestrian and you're a driver, if there's pedestrians and a drivers, it is the pedestrian who has the right of way all the time. And so if they step out into the road and they get hit, it is the driver's fault. Regardless that the car is tons of metal and the person is just a fleshy person. It's like, well, there's obviously one is significantly more dangerous than the other, uh, but it is still the pedestrian has the right of way. In Europe, the car has the right of way because it's a car, and it leans the responsibility on the person. Hey, don't cross the street if there's a car coming, because it's a car and you won't win. And so I think moving personal responsibility onto the person is.
I think that's
I
that's
definitely lean
generally my
towards it.
feeling is like if as a society we want to empower individuals to make good decisions
Mhm.
as kind of like a rule of
But at
thumb. We don't
but at the
necessarily
same
want to
time,
mandate. Go ahead.
but at the same time, got a lot of accidents from table saws that are just dumb problem or dumb accidents. It's not because the person wasn't educated. Just falls in the category of shit happens.
Totally.
And having that in there, if that is the major, and it is, that's the majority of the time that you get accidents, then I don't think it's that bad of an idea. Right now, it is just saw stop. Their cheapest table saw is like, I think, just under $1,000.
Yeah.
As soon as you give that into the market, then you've got
It's already so
competition, so
actually
makes it
so
cheaper
there's
and easier to
there have been
manufacture, and the
other
price goes down.
there have been other companies that are making them, and apparently they
Mhm.
were roughly the same price when they made their own models. I think it
Interesting.
was Bosch that introduced one that had a
Mm.
mechanism, and then they pulled it from the market, and nobody really knew why they pulled it from the market.
Oh,
But I mean, there's also the possibility that these things go wrong, and there's another side of this too, and that's if you have a market where there's some saw stops and some non saw stops, people get a little overconfident, and they start
yeah,
thinking it's not going to be a big
definitely.
deal if I make a mistake here because then the blade will stop it. And saw stop doesn't
Mhm.
always work. It's very, very often it works, but like it's like a worst case scenario. So do you get people then coming up to these things and treating table saws with less respect because they feel they have some safety
That's true. Yeah.
mechanism to, and I do think there's something to be said there. But anyways, I digress.
Do you know what I do
Jake,
want to see? Do you know that this does make me feel happier? That it is, they only make table saws. There are other tools that are also equally scary that I don't want to cut my fingers off. A bandsaw feels like an obvious one. I'm like, it's damn near the same technology. Like, just have like an electric sensor on the blade and then like a massive brake on the bandsaw. And I feel like as soon as that becomes more ubiquitous, then fantastic. Then workshops become safer.
yeah, I
Obviously the
mean
price
we
goes
can get
up.
on board for workshop safety for sure. But Jake,
Yeah,
that is our time.
I think that's all good.
This has
Yeah,
been the CADclass podcast. Thank you, everybody, for joining. Once again, I'm Josh,
I'm Jake.
and we will see you next week.
See you later, guys.